Hello everyone, my name is Kannika. I am studying in 10th standard in Adarsha Vidyalaya, Badami. Today I am going to tell you the topic of science, that is a periodic classification of elements. Do you know modern periodic table has a great history and it has the amazing facts. In this video we will know about the history of modern periodic table and its amazing facts. Also we will know about what were the scientists worked behind the modern periodic table and who was succeeded and who wasn't succeeded to attempt to classify the elements in the past. So let us know more about it. For studying so many elements as individually, we need to organize them appropriately. An organization begins with the arrangement. Arranging the various elements is the first step towards understanding their properties, and arrangement is possible only when we categorize them. This is how we organize the elements, and this process of categorization helps us study the elements with the ease. In other words, we have classified the elements here. Classification of elements means categorizing elements into groups based on similarities and differences in their properties. This is a modern periodic table. At present, there are 118 elements, out of which 94 are naturally occurring on the earth and the remaining 24 are synthetic. Elements which were colored by the pink are metals. The number of metals are present in the periodic table are 92. Elements which were colored by the blue are non-metals. The number of non-metals are present in the periodic table are 20. Elements which were colored by the green are metalloids. The number of metalloids are present in the periodic table are 6. Now it is a time to know how periodic classification was carried in the early days of emergency chemistry, when not many elements were known to the people. Now we will understand the various classification systems put forth by different legendary personalities. I already said that there were some scientists worked behind the modern periodic table. The works of those scientists are Dobereiner's Triads, Newland's Law of Octaves, and Mendeleev's modern periodic table. Now let us know briefly about them. First one is Dobereiner Triads. Who was Dobereiner? Dobereiner was a German chemist. He was born on December 13, 1718 at Auf an der Saale, Germany. His full name was John Wolfgang Dobereiner. He studied at the University of Jena and he became an assistant professor and then a supervisor of science instruction, and he died on March 24, 1849. This is a small introduction about Dobereiner. Now we will know about his work. In 1817, John Wolfgang Dobereiner, a German chemist, attempted to classify elements on the basis of their properties. He proposed the law of triads, which states nature contains group of three elements called triads. The physical appearance and reactions of the elements in each triad are similar. He classified the elements known at that time in a particular manner. He placed them into groups having three elements in each. Do you think these groups of three will have elements arranged randomly? Of course not. What is the unique way of the placing these elements then? It was a simple. Dobereiner arranged the set of three elements in such a way that is the average mass of atomic mass of first and third element in the set gave him the atomic mass of the middle element. In simple words, the atomic mass of the second element will be approximately equal to the average mass of first and third element. Let's take an example. One of triads he suggested was that consisting of lithium, sodium, potassium. The mass of lithium is 6.9 and potassium mass is 39. So if you take average, what would you get? You get 23, and 23 is the atomic mass of sodium, and this is exactly what Dobereiner had in his mind when he framed the triads. However, this is not perfect method of classification because not all elements follow this principle when arranged in triads. Also, when Dobereiner had put in this system, only few elements were known to him. Dobereiner could find only three triads at that time. Those are lithium, sodium, potassium. These are one triad, and second triad is calcium, strontium, and barium. And third triad are chlorine, bromine, and iodine. Now let us study about Dobereiner's method's merits. Is the Dobereiner's method gave a hint that atomic masses can be used as a criterion to classify elements, and demerits of a Dobereiner's methods are: first one, a large number of similar elements couldn't be grouped into triads. For example, iron, manganese, nickel, cobalt, zinc, and copper are similar elements but couldn't be placed in the triads. Second one, even a quite dissimilar elements could be grouped into triads. And third one, Dobereiner could identify only three triads out of the elements known at that time. Several elements were left out. Hence, the Dobereiner's method was not successful. Thank you.